Example 10.1, determine whether the given sampling method is independent or dependent. So for the first one here, a researcher wants to know whether the price of a one-night stay at a Holiday Inn Express is less than the price of a one-night stay at a Red Roof Inn. The researcher randomly selects 8 towns where the location of the hotels is close to each other and determines the price of a one-night stay. So the question is this an independent or is this a dependent scenario? In this case, this would be a dependent sampling. The reason this one is dependent is because the researcher is randomly selecting 8 towns where the hotels are close to each other. So once he picks a town that has basically, he's choosing the town, and then that town has to have Holiday Inn Express in it, and it has to have Red Roof Inn. So the selection of the town that has the Holiday Inn determines the Red Roof Inn that is also looked at. And so the selection of the first sample item determines the selection of the second one. So your 8 towns determine your Holiday Inn and your Red Roof Inn items there. Example B, a researcher wants to know whether the state quarters introduced in 1999 have a mean weight that is different from the traditional quarters. The researcher randomly selects 18 state quarters and 16 traditional quarters and compares their weights. This one is independent. And the reason it's independent, again, is because the selection of these 18 state quarters do not determine which 16 traditional quarters are selected. So again, the sampling of the first group is not determining the sampling of the second group, and therefore that is an independent sampling. For section 10.1, we start dealing with how to find these, how to test the hypotheses on these things. So 2 population means with unknown standard deviations. And we've dealt with unknown standard deviations before with 1 sample. And remember, with those, we have to do t-tests. To test hypotheses regarding 2 population means, mu1 and mu2, with unknown population standard deviation, we can use the steps from before, provided that the samples are obtained using simple random sampling, the samples are independent, the populations from which the samples are drawn are normally distributed, or the sample sizes are large, which means, again, for us, N1 and N2 have to both be greater than or equal to 30. And then for each sample, the sample size is no more than 5% of the population size. So it is the same conditions we had before. It's just that now we have 2 samples to work with. Our steps for hypothesis testing when we have 2 independent means. First of all, we're given our assumption and our claim. We're going to determine the null and the alternative hypotheses, just like we have done before. Next, we'll determine the type of test and draw a figure representing the type of test. Now, we're going to still do this, but this isn't as big of a deal for us because we're not going through the process of finding that test statistic because we're using the P method of doing these, but we're still going to want to have an idea of what's going on and whether it's a right-tailed test, a left-tailed test, or a two-tailed test. So anyway, number 2, we're going to do it, but it's not going to be a key step for us. Number 3, select a level of significance, alpha, based on the seriousness of making a type 1 error. If alpha is not provided, then assume that alpha is 0.5. And we've dealt with alpha before, and it's the same scenario when we deal with 2 samples, just like when we dealt with 1 sample. Step 4, the p-value approach. This is the one we're going to use. First of all, we're going to compute the p-value from the 2 sample t-test. That's just an option on our calculator, so we'll find that. Next, compare the p-value with alpha. And remember, if the p-value is less than alpha, we will reject the null hypothesis. And that means there is enough evidence to support our alternative hypothesis. And the result is statistically significant. If the p-value is greater than alpha, then we will fail to reject the null hypothesis, and there is not enough evidence to support the alternative hypothesis. The fifth step is to make a conclusion regarding our claim, and that means we interpret this in context of the scenario. So we've already practiced doing this before, and that's going to be the same as we've done previously. The calculator steps. So we're going to practice these, and again, we've done them. So if we're dealing with a two-sample t-test, first of all, if necessary, we will enter the raw data, if we have it, in list 1 and list 2. Then we will press stat and go over and highlight tests, and then we will select number 4, the two-sample t-test. Step 3, if the data are raw, then we highlight data, making sure that list 1 is set to L1 and list 2 is set to L2 on our calculators. If the summary statistics are known, then we will highlight stats and enter those summary statistics. So for example 10.2, a study is done to determine if Company A retains its workers longer than Company B. Company A samples 15 workers, and their average time with the company is 5 years, with a standard deviation of 1.2. That would also be years. Company B samples 20 workers, and their average time with the company is 4.5 years, with a standard deviation of 0.8 years. Assume the populations are normally distributed. So that's going to be important for us because notice we have less than 30 items in our sample, individuals in our sample. Conduct an appropriate hypothesis test at a 5% significance level. And that's going to mean alpha is 0.05. So now I've boiled this down a little bit so we'll have some space to write. First of all, let's start by identifying a couple things. Our null hypothesis is comparing the two means. So the null hypothesis, remember, is a statement of equality or no change or no effect, and that means mean from company A, I'll just make it company A, is going to be equal to the mean of company B. And so that is our null hypothesis. The alternative hypothesis, that should be just a 1, not an I. The alternative hypothesis, if we look at this, the question they're asking is if Company A retains its workers longer than Company B. So that means the alternative hypothesis is that the mu of Company A is greater than the mu of Company B, the average for Company B. So now let's see what the information is that we have, and we want to get in the habit of writing these things down. So Company A samples 15 workers. That means N1 is 15. Company B, let's see, the average time is 5 years. That means X bar sub 1 is 5 years. The standard deviation for Company 1, so S sub 1 is 1.2. Then we have Company B, and I'm going to call that N2, and that is they sampled 20 workers. Their X bar for Company 2, Company B, is 4.5, and the standard deviation for that company was 0.8. Our alpha value is 0.05, and that is from this statement right here. Now that we have all of our information, we're ready to go enter this into the calculator. So notice when we do this, we don't have the raw data, we have the statistics. So we're going to go to stat and over to tests, and we're going to go down, if you look at this, number 4, the two-sample t-test. And again, we use that because we do have 2 samples, and we are comparing means, so that would either make it a z-test or a t-test, but we do not know the population standard deviations, and just like before, that means we're dealing with a t-test. All right, we don't know the data. We're going to go over to stats and hit enter. So X bar 1, we know that is 5. S1 is 1.2. N1 is 15. X2 is 4.5. S2 is 0.8. And N2 is 20. Now, here's where we have to write down our alternative hypothesis, and notice that is right here. And I guess I used 1s and 2s on all these other numbers, so, and that's what they use is 1 and 2. So we want mu of 1, which is what this says, mu of 1 to be greater than mu of 2. So we've got to go over and highlight that third option. So we're going to hit enter right there. Then we'll go down. We don't need to worry about pooled. That's going to be no. And calculate. Now that we've got this, let's write down what we get. Now notice a couple of things. First of all, they give you the t statistic, and sometimes in our problems that we have for homework, they ask for that t statistic. So that's where you find it. It'll just say t equals, and usually they'll round that off to probably 2 decimal places. So you might want to point out that t equals 1.40. Okay, that comes from right there. And then the p-value, which is what we're going to look at right now to make our decision, is that p equals 0.0878. And we want to compare that to alpha. And in our case, p is greater than alpha. And so if we think about what that means in our scenario, that means we will fail to reject h sub 0. And that means, in summary, there is not enough evidence to support the claim that company A retains its, I'm going to put ... but that company A retains its workers longer than company B. For example, 10.3. Now we have a researcher who wanted to know whether state quarters had a weight that is more than traditional quarters. The researcher randomly selected 18 state quarters and 16 traditional quarters, weighed each of them, and obtained the following data. So this is the example we were given earlier, and we already determined this is independent. So this time, notice we're given the actual raw data. So we're going to go to Stat and Edit. And notice we have to put these values in our list 1 and list 2. If you have values in yours, you're just going to go up and highlight L1, hit clear and enter. And then we've got that. So let's enter these in. 5.7, 5.73, 5.7 again, 5.65, 5.73, 5.79, 5.77, 5.7, 5.73. So that gives us our first 9. Then we go to the second column there, 5.67, 5.61, 5.67 again, 5.62, 5.65, 5.73, 5.71, 5.76, 5.72. So that's our first row. We've got our 18 values entered there. We're going to go over to list 2. We've got 5.67, 5.7, 5.72, 5.66, 5.7, 5.68, 5.67, 5.61. And that's our first 8 for that list. We go on to the second column there, 5.55, 5.61, 5.58, 5.71. Oh, that's a 7.4. Hope I didn't mess up any of those other ones. Okay, 5.68, 5.53, 5.55, 5.74 again, it looks like. On my screen here, it's hard to see which ones are 7s and 4s on some of those. All right, so looking at this, we have our 16 values there. We have the raw data. We're going to go to Stat. We're going to go over to Tests Again, we're going to select number 4 for 2 sample t-test because we've got our 2 samples and we do not know the population standard deviations. But this time we have the data. So we're going to go to enter right there. We're going to go down to L1, that's where we put our list 1. L2 is where we put our list 2. If you don't have that there, you're going to go second 2 for L2 and second 1 for L1. The frequency should be set at 1 for both of these. Now, we have not done this yet, so let me go to the next slide. And now let's state our stuff here. H sub 0 is still that the 2 means are the same. H sub 1, the alternative hypothesis, will be, so test the claim that the state quarters have a mean weight that is more than, so the state quarters are our first group, so mu sub 1 is greater than mu sub 2. That is our claim. I should have noticed, or I should have mentioned the claim on the previous one there also. Notice a normal probability plot of state quarters indicates the population could be normal, and a box plot indicates no outliers. The other thing to think about is the number of traditional quarters. There's so many, we're pretty much guaranteed that that is going to be a normal distribution. Notice I did give us the summary statistics here, but we're going to actually see those in just a minute as we do this problem, I believe, anyway. So let's take a look. But we want mu sub 1 to be greater than mu sub 2, and it was already highlighted from before. It is not pooled. We're going to calculate. We hit enter. And notice our t value is equal to 2.54 if we round that off. Our p value is equal to 0.0086. And then our alpha value is alpha equals 0.01. So now we're comparing these two. P is less than alpha. So our decision here is that we will reject the null hypothesis. Okay, and we'll talk about what that means in a second. But I just want to make note here on the calculator. Notice you can see the mean 5.70 for the first group, the mean 5.65 for the second group, standard deviation for that first sample 0.049 or 0.050, and then for the second group 0.069. And yeah, we've got our number of values there, but it gives us all that information that we had to just enter in the previous example. So now, since we have rejected the null hypothesis, we can state, I'm going to use green here, there is enough evidence to support the claim that state quarters are heavier. And again, we're back up to here. So the claim is actually, sorry, that the mean weight of state quarters is more than the mean weight of traditional quarters. So that's, you're always looking at, is there enough evidence or is there not enough evidence to support that claim? So that is the end of section 10.1. You've got 3 graded problems there to work on. Don't be afraid to ask questions on those. There are only 3 problems because we're covering a few sections and they're all very similar. So it's just a matter of making sure you choose the right type of test and then making sure that you answer those questions with the correct information that we gather from those tests.